One is called predictor, and then the other one is called corrector. So if you combine both, then it becomes Yoon's method. We will see later what is that. This is just an explanation. So to improve the approximation, Yoon's method adopts the use of two derivatives for the interval, one at the initial point and the other at the end point. So we want to see what is that improvement, because all these methods that you studied in a previous lecture, Euler's method, is approximation. This is the key word, yeah. So this approximation can be improved. That is what this method all about. Improve the Euler's method, because Euler's method is an approximation method. So the two derivatives are then averaged. Averaged derivative, the dy dx, to obtain an improved estimation for the entire interval, because we are looking at interval from lower bound to upper bound. So we take the average. Of course, this will be given in the form of formula. Okay, you can you look at the slide number 6. The formula, Euler method, we have to recall back, is given this form. Normally, the subscript is not written in the solution, but we have to know that this is y of xi plus 1 equals to y of xi plus hf xi yi. So your y is the output, x is the input. So xi plus 1 is next x after xi, because I can run from 0, 1, 2, 3, 4, and so on. So if I substitute subscript, normally the subscript is not written, but it is better for you to write the subscript. If I substitute I with 0, 0 plus 1, 1. So yx1 equals to yx0 plus hfx0 y0. So you are calculating the output y for the next I or next x, where step size is h. This step size you already knew from previous lecture, is equals to hb plus a over n. b plus a over n. So what is this fxi yi? Is called y dash. This one, fxi yi, is equivalent to the y dash. So this fxi yi, you must get it from dy dx. So this is Euler's method. Now, Yoon's method, we have predictor equation. Predictor equation means you estimate, you predict, or you forecast. This predictor actually comes from Euler's method, but we put the y superscript not 0. This to indicate that this is predictor. So you don't forget to put this, because we have predictor and corrector. So how to differentiate? So the y0 xi plus 1 calculated is not the final answer, not yet, but an intermediate prediction, an intermediate forecast. Because predictor, corrector, 2 steps. So this one is an intermediate step, an intermediate prediction. You are predicting the output, why not? We can call this as an initial prediction. So if you observe carefully, this formula, exactly Euler formula. So Yoon's method, making use of Euler's method, but we call this as a predictor equation. Now, after you calculated y naught, because this is the calculation, you know y xi plus you know h, you know f xi yi. All these can be calculated. This one can be calculated. So therefore, you can calculate y naught. So after this, you have to find the corrector equation. The corrector equation, we have to take the average for the interval. This is the average, y dash bar, y dash xi plus y dash xi plus 1 divided by 2. This is what they explained just now, the average. So this one, y dash, because we have already written fxi yi. So we write fxi yi plus fxi plus 1. So the next x. And then this y naught I plus 1 comes from this one. Yeah. So you take all these things, the y, you plug inside here. But this one, this is called the y dash bar. You put it here because this one average. So the final answer is y xi plus 1. This output equals to y xi. This whole thing class goes inside here. This one. You plug inside. This thing, you plug here. Because you know y xi. This is the previous one. This is the next one. So the whole formula is called Yoon's method. But if you look at carefully, the Yoon's method, only this part is different from Euler. But he is using Euler's method again, but in more comprehensive form. That means you have averaged. So this is very good approximation. Okay, now in order to understand this, we have to solve the problem. That is where you have to spend a lot of time. You have to practice using calculator. Take your calculator with you now because we are going to do the experiment, numerical experiment, validate, verify, and you test the method, how far this method can give you a good solution. Good solution meaning very good in accuracy. So throughout your exercises later on, and then you can experience yourself, the finding will show that Yoon's method is better than Euler's method. Yoon's method better than superior to Euler's method. But this yet to be proved because you have to practice by yourself and you can find your own conclusion or findings. Okay, now this is the simplified version. What is Yoon's method? You have a predictor. This is y superscript naught xi plus 1 equals to y xi plus h xi yi. And the corrector, is the final one. This is y xi plus 1. This is your final output class. This is the output you are looking for at that particular input x. In this case, I plus 1. Remember, yeah, this formula, you may say it's very hard to memorize, but you must be very familiar with this. The important thing for you is how to use this formula in a correct way. So yxi plus 1 equals to yxi plus h in the bracket fxiyi plus fxi plus 1 y naught I plus 1 divided by 2. So this corrector will give you the final answer. Now, after you studying Yoon's method, you can do comparative studies. Compare with the Euler's method, and then you can see the difference, and then you can find the error, how much the error is. That will be the next stage. Now we want to solve this problem. Question must be clear and full information must be given. Here there will be some problem because it is not like Laplace transform. It is not like constant coefficient, homogeneous, non-homogeneous, where you use Wronskian method, undetermined coefficient, Cauchy-Euler, Bernoulli, linear, exact, non-exact, separable. Because here we are talking about the interval. Okay, read the question carefully, spend more time doing exercises because the formula is straightforward. Using the Yoon's method, so clear, yeah, you cannot use Euler's method. Solve the following differential equation, this one, dy dx equals to 4e power 0.8x minus 0.5y. Now get ready your calculator. Yeah, at the moment we need the calculator to calculate the values. We are doing manually. Manually. So you want to solve this problem from x0 to 2. So what do? You have to draw one line like this. Draw one line, and then the lower bound x2, x0, and upper bound is 2. So this is the meaning. So you are given the interval 0 to 2, 0 to 2, with the step size h equals to 1. Now this one you must understand. Given y naught equals to 2, y0 is 2. So this statement must be clearly understood. Otherwise, you will have different values. You must remember the method is already clearly explained. You cannot have different answers unless you change the method, because this information is clearly given already. So you cannot change this. For example, x you put as 3, cannot. 3 is outside this interval. So what is the meaning, class? 0 to 2 meaning with the step size h1, that means at x equals to 0, what is the output? Output is 2, already given. This is called initial value problems, and then the condition is called initial condition. Y at x0 is 2. That is the meaning. X0, not these 2. This is your y output. Step size h1. So after x0, the next x is 1. How do you get 0 plus 1? So at x equals to 1, what is the output? Not given. We are now going to find that. And then the next x is 2. What is the output? We call it Y2. This one is Y0. This two is Y0. Which one? This one is Y0. This two is called Y0. And this one is called Y0. Y1 is at x equals to 1, yet to be found. Y2 is at x equals to 2. We have to stop there. Where to stop? This is one of the most important criteria in numerical method. Where to stop? This is what we call stopping criteria in artificial intelligence. We have a method like fuzzy logic, genetic algorithm, neural network. The major issue is where to stop. You see, in Laplace transform we don't have a stopping criteria. It is auto stop. It will stop by itself once you found the solution. But here, not like that. If I change x, for example, 1 to 3 is different. So I have to do 1, 2, 3. For example, here 0 to 10. So 0 to 10 means I have to do here 0 to 2. I have to do 2 iterations. If 0 to 10, I have to do 10 times, 10 iterations. That word is missing here, which we call it as iteration. Iteration means you repeat the process number of times. Depend on the age. If in this case h is 1, if I put h 0.5, is different. Meaning you have to do x0, 0.5, 1, 1.5, 2. So class, this h is important. And this why not? When x0, y is 2. This is called initial condition. If this one not given, we cannot do. So very difficult. So in the problem, you must have this initial condition. This problem designed or constructed with this initial condition. If the initial condition change, the final output will be different. Okay, now take a piece of paper and pen, yeah, and calculator. We are going to solve this. This is solution now. Solution, step 1. What is step 1? Predictor equation to estimate y at x equals to 1. At x equals to 0, you already knew 2. That is the initial condition. You can see here. So you don't forget to put y0, because this is what is about the predictor. So when we see y0 superscript, yeah, y superscript naught, that means we know this is predictor. So if you don't put then it's very hard to recognize, identify which one is which. So you got to do a very systematic way. Y0 xi plus 1 equals to yxi plus hf xi yi. So this formula is given already. So we cannot question this. What is important is how to calculate this. So y0, they put the x is 1. That means the x1. I write x subscript 1. I put I equals to 0. If I put I equals to 0, then this is x1. So fortunately, x1 here is 1. This one is x0. X0, this is y0 plus hf x0 0, y0 is 2. You put it here. So now this is your fxy. Write down, yeah. Fxy equals to, now this fxy is equivalent to this. Don't forget this, because this is your dy dx. In differential equation, because differential equation you have dy dx, but in numerical method we don't have dy dx. We have to write this, just a format. So how to calculate f02? You have to use this one. This is the point. That means f y0 you already knew 2. So you substitute 2 here now. You are calculating y0 1. This is your intermediate output. So y0 is equals to 2. You already knew this. Put here 2 plus h. You already knew 1. So just plug in 1. No problem. F02, that means the x is 0, y is 2, equals to, calculate now class, 4 multiplied by e power 0.8 x0. X0 here, this x is 0, minus 0.5 multiply y. Y is 2. This y is 2. So you calculate this. This is the problem. Many students ask how you calculate this. This x is 0, y is 2. From where? From the initial condition. Now f02 you must calculate from here. I repeat again. 4 multiplied by e to the power 0.8 multiply 0. So e power 0, 0. 4 multiply 0. E power 0, 1. Because x is 0. 0 multiplied by 0.8 is 0. So e power 0, 1. So this is 4. Minus 0.5 multiplied by 2. This is half 1. So 4 minus 1. Answer is 3. So you see here. Next slide. Yeah. So y0 is 2. H is 1. You must calculate this class. Use your calculator now. F02 is 4 multiplied by e power 0 minus 0.5 multiplied 2. So 4 multiplied by e power 0 is 4 minus 0.5 multiplied by 2 is 1. So 4 minus 1 is 3. Please use your calculator or your whatever your instrument you have. So you can use your calculator, calculate this. Otherwise cannot. So you have to spend time here, class. The method is already given, straightforward. The most important thing is your calculation. That's why they use the software programming, a lot of things to calculate this, because this will be very tedious if the equation is very long. This calculator can be used for 2 terms, okay. If you have 10 terms, then it will be very lengthy. Okay, what is important here is you have to calculate the y0 at x equals to 1. This is the next x. So y superscript not 1 equals to y0. Y0 you already given 2. Answer is 2. Plus h is 1. Just substitute h1. F02 is 3. So you put 3 here. 1 multiply 3, 3. 3 plus 2 is 5. So the answer, the intermediate output, the predictor, is equals to 5. So the y0 1, 5, you have to substitute inside the corrector. So we want to calculate the corrector. So this is your final output at the next next x. That is at x equals to 1. Y1 equals to y0. Y0 you already knew. That is 2. You already knew 2. y at x0. Now this one, hf, the initial x is 0, initial y is 2. This is 0, 2. And this next x is 1. The next y, this one, y naught is 5. This is f15. This is the problem class. This one, f15. This is I plus 1. This is I. You have to recognize this carefully. Watch this carefully. They are not same. This is called averaged. This is xi, yi. This is 0, 2. This is the initial one, initial x. You started with x0, yi. This is y at x0, 2, given. This is given. Now the next x is 1. The y naught that you found just now is 5. So this f15 not yet found. So you have to calculate this. You have to calculate this one. So use your calculator, check now. This one you have to verify. You let me know because you are the one doing now. So please pay attention. F15 is equals to 4 multiplied by e power 0.8 multiplied by 1x minus 0.5 multiplied by 5. Do it now with the calculator. Can you get 6.402164? Can you get the answer, class? Hello? Hello? Can you get the answer, class? Please answer. Chia? Please check your calculator. Reply to me. Okay. So you got this. 6.402164. You take this value, put it here. Okay. F02 is 3. So you already calculated already. F02 is 3. F02 is given already. This is 3. Already found. So put inside here 3 plus 6.402164. Put it here. And then h is 1. This h is 1. Y0 is 2. So you can calculate y1. This is the method. You use your calculator now. Y1 equals to y0. Y0 is 2. H is 1. F02 is 3. Plus F15, 6.402164. We take for 4 decimal numbers only. If you want to increase, can, but not necessary. Minimum 4, and then maximum we make it 6 decimal points. If you want to have more, can, but not necessary. Make sure you have this 6.402164 plus 3 divided by 2. Calculate now. Plus 2, you must have the answer, this one. If answer is different, please let me know. We will do the correction. So at x equals to 1, we call it y1. The output is 6.701082. This value cannot be very different when each one of you solve this problem, because everyone using the same method, Yoon's method. Unless you use Euler method, then you have different answer. But at the moment, we want to use Yoon's method. So the answer is 6.701082. So can you verify this, class? Arif Akimi, can you verify? Can you please confirm with your calculator? And y y at x equals to 1. Answer must be at x equals to 1, 6.701082. So you must confirm this first. Okay. Now at x equals to 2. So this one you have to check. You have to do so use your calculator now. At x equals to 2, first y naught xi plus 1, yxi plus hfxi yi. This is the predictor. Now we are doing the last x. We have to stop at x equals to 2. So you have to again repeat the 2 steps again. That is predictor and then corrector. So we are finding the y naught at x is 2, the next x. For x equals to 1, you already found the y, this one. This you already found. But we need this, because this one you're going to put inside here. That's why the first step, you must make sure you do it 3-4 times correct. If the first one is wrong, this one, of course, this will be wrong. That is the disadvantage of this method. Because this y naught 2 depend on this, which you calculated just now. Because you are using this formula, you are repeating the same formula. That's why we call this as iteration. Because the formula is one only. It's a very simple formula. We have to repeat in order to get accurate answer. And that is the challenge class. That's why every one of you will different answers. But to avoid that, better you check 2-3 times. You check. So y naught at x equals to 2 equals to yx1 plus h is 1, f of xi. This is the x. The currently is 1. And then the y correspond to x is 6.701082. That is what you found just now. So you are improving. You are using the next x. This is x1. Using x1, you are finding the output for x2. That is the meaning. But this is the output, you get it from here. Yeah, when x1, your y is 6.701082. But this one not calculated yet, because this one is the one we have to calculate using this formula again, the equation. This one you have to use calculator now. This one you have to calculate now. That is f of 1 x1 y 6.701082. So this will give you 4 multiplied by e power 1 minus 0.5 multiplied by 6.701082. 4 decimal points. You use your calculator, see whether you can get this or not. Now, yeah, you don't wait. Now we have to verify. So 4 e power 1, you have to calculate. Use the calculator. E power 1 multiply 4 minus 0.5 multiplied by 6.701082. You should be able to get 5.551622. This you have to do real-time experiment, yeah? A numerical experiment. Can you get this, class? Hello? Waiting. I'm waiting. Can you get? Please answer. Chia. Can you verify? Hello? Hello, Chia. Wong Chen. Did you get that? Got the same. What about others? You have to do the experiment class. We are just like in the laboratory now. We have to do the experiment. This is called numerical experiment, computational experiment. So you have to verify. If you don't get it, something wrong. So I'm waiting now. Please, others. Where are you, Muhammad Amirun? Muhammad Amirun? Chia, no reply. Muhammad Azim? Amirul? So you got the answer now. Muhammad Zafir? Shakir? Patricia? Sorfina? Noor Ain? Still trying. Faster, faster please. Shahira, did you get? Cancer. Muhammad Nabil, very good. Muhammad Amirun. Muhammad Aiman, what happened? But sir, I got 7 point. Chia. Chia. Yeah, it should be, yes, yes. It should be e power 0.8. Yes, sir, sorry. Yes, yes, yes. Sorry, sorry. E power, yes, 4 e power 0.8. 0.8. Yeah, multiply by 1. Yes, yes, yes. 0.8. The 0.8 is missing here. This one is wrong. Sorry. So answer is correct. Answer is correct, right? Answer is correct. Yeah. Chia, answer is correct. Agreed? Yeah, answer is correct. Agreed. Okay, 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 good. Okay, okay, okay. The answer is good. Typo error. P-Y-P-O, typo error. Printing error. All right, now we proceed. Yeah, okay. Sorry about that. Now 5.551622, you put inside the predictor equation now. Watch this carefully. Sorry, why not 2? Why not 2? Still, why not 2? Y1, this one, 6.701082. H is 1. Take it, put it here. Please follow me here. F of 1, 6.701082, this one, is equivalent to 5.551622. Okay? Five point 551622. $5.551622. Now, take your calculator, calculate. Y1 6.701082, this one, plus with 5.551622, you should be able to get 12.252504. Could you please do it now? I'm waiting, yeah? 6.701082 plus h is 1, 5.551622. If you add these two together, you should be able to get 12.252704. This is your y naught at x equals to 2. Can you verify this, class? 12.252704. Okay, good. Okay, all right. Now this is predictor. Now we move on to corrector. Next one is the corrector at x equals to 2. So we are using this formula. Don't use the previous formula. Use this formula. Yxi plus 1 equals to yxi plus h, fxi yi plus fxi plus 1, y naught I plus 1 divided by 2. So at x equals to 2, this is y1 plus h f1, the y is 6.701082 plus f, the xi plus 1 is 2, this 2, this 2 here, and then your yi plus 1 naught must come from here. You take this, put it here, not calculated yet. This one now we want to calculate. This one we already have. y1 6.701082. This one you already have. And this one also you already have. This one you already have. So this one 5.551622 we already have. Only thing is this one we don't have. So now use your calculator, calculate this one. F of 2, 12.252704 for 6 decimal only, equals to 4 multiplied by e power 0.8 multiplied by 2. This is 1.6. 4e power 1.6 minus 0.5 multiplied by your y, that is 12.252704. You calculate now. Please calculate this value and see whether you can get this or not. Is this correct? 13.685773, or if there is any mistake, please let me know. Calculate this now. Four multiplied by e power 0.8 multiplied 2 minus 0.5 multiplied 12.252704. Can you verify? Hello? I'm waiting, yeah? Yes, Chia. Can you verify? Nur Fatia, Wong Chen, Aishu and Muhammad Nabil. Check the decimal number. Check the decimal number, please. No, Chair. Please check. There is a problem here. Is this correct? Correct? Double check, please, class. Six decimal number only. 1, 2, 3, 4. 1, 2, 3, 4. 6. So 13.685777. 685777. Okay, 13.685778. 6 decimal number. Okay. Okay, let us see. Okay. We proceed now, yeah? Okay, next one. Next. Please follow, yeah? Next one. So you have to take this whole thing, put it inside here. Now I'm using this value. So you say just now 13.685778. Okay. So you change the 3 to 8. Now we want to calculate Y2. So you plug in Y2 equals to Y1, that is 6.701082. This one is okay. H1, F of 1, 6.701082 is this value, 5.551622. And then F of 2, 12.252704, 13.685778. You add these two, divide by 2. Okay, with this 8, yeah. You add and divide by 2, multiply by 1, plus 6.701082. See, you get this answer now. 16.3197. This one 81. I repeat, yeah, 16.319781. You verify this. That is at the Y2, you should get this. But this 7, this one should be 81. Can you verify this, class? Please verify. Yes, Chair. 319782. 16.319782. Okay. Because just now you round up. Okay. Okay. Can be accepted. Muhammad Shah, Shalihin and Muhammad Amirun. 16.319782. Okay, 8182, yeah. It's okay, yeah. Okay, anyone else? This is +1. Okay. Anyone else? Question, please. So, the final answer, this is your y at x2, 16.319782. You got it, 82, right? So this is the output at y2. So we already have this answer. That means you already solved successfully. You already solved successfully this problem. So go back again. I repeat again, yeah? So go back again. So this problem, we are solving this problem from 0 to 2 with the step size h1 with y0, 2. This is the starting point, x0. So at x0, y is 2, already known. At x equals to 1, we found out your y is 6.701082. That is output at x equals to 1. At x equals to 2, you found out y2, 16.319782, according to your answer, 82, right? Are you agree with the answer, Chia? Chia? Can you verify, Chia? Where is Wong Chen? Wong Chen, are you there, Wong Chen? Wong Chen? Where are you, Wong Chen? Agree. Okay, thank you, Chia. Okay. Now, when x approach to 2, you have to stop. You no need to proceed to x equals to 3 unless you ask to do so. Okay, any question, class? Any general question on this? For example, this example, any question? Any steps not clear? Wong Chen said, okay, clear, sir. Thank you. All right, you're welcome. Others? Anyone else? Patricia Sorfina. Patricia Sorfina. Mohammed Aiman. Sir, is it recommended to round off 7 decimal first or final answer? It's up to you. Yeah, it is up to you. Chia. It's up to you because it is iterated. This is not precise. This is iteration method. So, iteration method, you have to approximate using your own judgment. So it's very difficult. Yes. From the beginning, if you stick to 6 decimal points throughout your calculation, 6 decimal points. If 7, then 7. It is up to you. But we will check accuracy of this. Because you no need to wait until the end. You can round up in the early stage. It's up to you. We understand this is approximation method. You must know the philosophy of this method. This is approximation method. If your answer is 5 decimal point correct, okay, we accept it. 6 decimal point correct, we accept it. 7 decimal point correct, we accept it. But we cannot keep on increasing the decimal numbers, class. You must remember, this is, you see, this is time-consuming method. Another disadvantage, takes a lot of time. So we cannot spend time because it's already it's a lengthy iteration process. You must focus on the iteration. Decimal number is what we call secondary things. The iteration you must carry out. Normally we go for at least 4 or 5 iteration class. The example you saw just now, 2 iteration is insufficient. Now, the last one, yeah, this one. After that, we will stop. Okay. So we will do the revision again whenever there is a time. So look at this example. I will do one iteration for you, and you can do another iteration when you are free. Look at example 2. So I have done for iteration 1. Iteration 2, you can do yourself. The question must be very clear. If the question is not clear, please ask now. Don't wait until last minute. You can ask now or in the next lecture immediately. So don't send an email asking question because it's very hard for me to answer via email. It is better real time. That means now. But it can be from previous lecture. You can stop me for a while and I can answer. So now we are focusing on Yoon's method. So the question, using the Yoon's method, solve the following differential equation. You can solve this problem using separable class or using linear equation method, finding integrating factor. So the advantage is you can compare with that method the final solution at that particular point. The integrating factor and then the separable, we don't have interval, but you can find at that particular point. You substitute using the initial condition, find the C, and then you find the Y output. The end game here is what is the output. Now, this is your fxy, x multiplied by root y, that means y power square. From where to where? From x1 to 1.2. So write down, put a line here, one line, straight line. X starts from 1, lower bound is 1, upper bound is 1.2. From 1 to 1.2, with the step size h 0.1, initial condition y1 equals to 1. What is the meaning? That means when x is 1, your y is 1. It's already known. At x equals to, next x is 1 plus 0.1. The next x is 1 plus 0.1 is 1.1. We call that as x1. The next x. You start with x1. This x is 1. Same as this x here, 1. So the output when x1 is already known. If we don't know this, then we cannot do anything. Sorry, we cannot start. Because this is iteration. iteration method, meaning you must start with iteration number 1. How to start? You need the initial condition. This is the prerequisite. You no need to create this. This is already given to you. It's already given. If it's not given, we are in trouble. Of course, you have to ask. This information is missing. Now, when x1, y is 1. Very simple, class. When x 1.1, what is your y? We do not know. We want to find. How to find? Must use Young's method, or use Euler's method, or use any other method. Now, x 1.1, what is your y? We don't know yet. We want to find. And because 1.1 is the next x, and after that, the last x is 1.2. That is 1.1 plus 0.1. 1.1, write down here, 1.1 plus 0.1, 1.2. So we already reached the end point. If you put 1.2 plus 0.1, then 1.3. 1.3, no need to find. But if you want, you can, but not necessary. Because this interval is very important. Where to start, where to stop. If you don't fulfill the criteria, then you are in the wrong. So how do we do that? You repeat the same again process. There is no answer given. You write down now. I'm repeating. You use the formula. Go back. So this is the last slide, class. So I give you the y at x equals to 1.1. You write down, then go home, you calculate. Start, yeah? I show you. Go back to the original one. This one, yeah? So your dy dx is x root y, okay? That is your fxy. Write down, yeah? So y superscript naught x1 is y x naught plus hf x naught y naught. So y power naught is y1 plus 0.1 f11. So I write down here, but it will be very hard for me. So at y superscript naught, yeah, y superscript naught is at x1 1.1 equals to, I write down here, 1.1 is y1 is 1. I straight away write here, plus h is 0.1 multiplied by f11 x1 multiplied by root 1 is 1. So f11 is 1. 0.1 multiplied by 1. So the answer is 1.1. Can you get this first? This is y superscript naught at 1.1. Is y1 is given already, 1. You are given y at x equals to 1 is 1. Plus h, the formula says h 0.1 plus f of 1, f of 1, you must put inside the dy dx. That is your fxy. x1 multiplied by root of 1 is 1. Root 1 is 1. 1 multiply 1, 1. 1 multiply 0.1, 0.1. plus 1, 1.1. Can you get this, class? Chia? Are you there, Chia? Okay, very good. Okay, now y at 1.1. So corrector. So now I write C, yeah, corrector. So the corrector, now we want to calculate y at 1.1. And this is corrector. So y at 1.1, y1, 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 1 plus, slowly, yeah, h 0.1 bracket f11, f11, f11 you already calculated is 1 plus, now you calculate f of 1.1, 1.1, because x 1.1, your y naught 1.1, your y naught is 1.1. So f of 1.1, 1.1 is equals to x 1.1 multiplied by root of 1.1. What is the answer, class? 6 decimal point. So you should be able to get 1.15368 like that. Can you get that, class? And then this one you have to divide by 2. Estia 1 plus 0.1 in the bracket 1 plus 1.15368. I put 5 decimal number only. It's up to you. So now you calculate 1 plus 1.15368 divided by 2 multiplied by 0.1. So you have 1 y at 1.1 equals to 1 plus 0.1 multiplied by 1.07684. Five decimal number. So if you add these two, this 1.07684 multiplied by 0.1 plus 1. So your y at 1.1, this will be equals to 6 decimal, 1.107684. This one is 6 decimal. So We already calculated the output at x equals to 1.1. Your y is 1.107684. You agree or disagree, class? I'm waiting for your answer, please. Chia? Where is Wong Chen? Bhaktiyar, Hamad Bhaktiyar. Okay, Sharifa is okay. You may wonder 5 decimal, why I changed 6 decimal here. This is up to you. If you go for 5 or 6, it's up to you. Yeah, Chia, can you verify, Chia? Thanks, Mohammed. Thanks. Yeah, Wong Chen, where are you? Wong Chen. Wong Chen. Minimum decimal place wanted. It's up to you. 5 to 6. Okay. Maxwell, he has left the meeting. What happened, Maxwell? Maxwell Lee. Okay. So now I give you a homework. So the next one is you go home. You try y and 1.2. This one you try, but I don't have the answer for this. You use the Yoon's method. Yoon's method, predictor and corrector. Repeat the same thing. I repeat the same thing. Whether it is 5 decimal or 6 decimal, it's up to you. But we will see by checking your answers, we know. It's not so important because if your steps are correct, then the decimal number is minor. Of course, for the accuracy purpose, we will check. It is better you be consistent. Sometimes you round up to 5 or 6, so we will know. It will not affect very much because when you started the iteration, you already fixed already 5 decimal number. So we follow according to your steps. If somebody use 6 decimal place, we will follow that. If you do manually, so any question, class, before I stop here? So this is the last slide, which I already shown to you. So exercises for this will be uploaded later. So you have 17 slides only. Next week we will start with so final one on numerical method. The last topic will be on Rangi Kota. Okay. So any question, class? Before we start, please fill up. Please fill up your satisfaction poll, class. Satisfaction poll. Please fill up your satisfaction poll, and then please attend your online assignment. Five question, 5 questions. 3 hours. Any question, guys? Any question, class? Before we stop. Any question, class? Regarding your quiz 1, replacement quiz will be done next week. We will try. Those of you miss quiz 1. Anyone here missed quiz 1? Those of you missed quiz 1, please email me. Raza Sweet. Let's wait for the replacement quiz. Please do your assignment first. Nur Ain, don't miss assignment, online assignment. Raza Sakib, please refer to your ULearn for the online assignment. Any more question, class? Raza Sakib, yeah. Okay, so shall we stop here? Shall we stop here? Okay, thank you very much. I see you again.